Geometrical interpretation of indefinite integrals. In this module, you will learn about the geometrical interpretation of indefinite integrals. Suppose an object moves with a velocity v expressed in meter per second, defined by the equation v of t is equal to 2t, where t represents time in seconds. Can you determine the displacement s of an object at any time t greater than or equal to 0? Since velocity is the derivative of displacement, to find the displacement, we must define the displacement s of t. In other words, we need to find the function s when its derivative is already known. To do this, we need an operation that is the reverse of differentiation. This inverse process of finding the original function when its derivative is given is known as integration or anti-differentiation. Suppose capital F of x is an antiderivative of function fx. Then for each x, the derivative of capital F of x is equal to f of x. The value capital F dash of x is the gradient of the tangent to the graph of the capital F of x at point x, capital Fx. As capital F dash x is equal to f of x, the gradient of the tangent to the graph of capital F of x at point x, capital Fx, is equal to the value of the function f at x. Now consider the graphs of functions capital Fx, capital Fx plus 1, capital Fx plus 2, capital Fx minus 1, and capital Fx minus 2. If the graphs are intersected by a line x equal to a and tangents are drawn to all the curves at the point of intersection of the curves by the line x equal to a, the tangents obtained are parallel to each other, representing that the gradient of each tangent is same. Since the gradient of the tangent at a particular point represents the derivative of the function at that point, the functions capital Fx, capital Fx plus 1, capital Fx plus 2, capital Fx minus 1, and capital Fx minus 2 have same derivatives at the point of intersections of the curves by the line x equal to a. This helps us to conclude that many functions can have the same derivative, say f of x. Conversely, you can say that the same function has many antiderivatives. Thus, we can conclude that the antiderivative of a function is not unique. In general, capital Fx plus a real constant c represents a family of antiderivatives of Fx. The set of all the antiderivatives of f of x is called the indefinite integral of f of x. It is denoted by the following symbol. If capital F of x is the antiderivative of the f of x, we write as follows. The function f that is being integrated is called the integrand, and the variable x is called the variable of integration. In this module, you have learnt that integration is the inverse process of differentiation. An indefinite integral is a collection of family of curves. The symbol integral of fx dx stands for the collection of all antiderivatives of f.